Hi everyone, this is Miss Moriarty and I'm here to discuss with us our topic 8.7, which is all about persistent organic pollutants, or in short can be called POPs. So in looking at persistent organic pollutants and what they are, it kind of goes with their name, right? Persistent meaning long-lasting, organic means carbon-based or comes from a living organism. So persistent organic pollutants are actually synthetic or man-made compounds that do not easily break down in our environment, and as a result can accumulate in our soil, water, as well as actually the fatty tissue of a lot of organisms. Compounds that fall into this category can come from things like pesticides, pharmaceuticals, military compounds, industrial compounds. And why they cause such a problem is because they're very long-lasting, right? They don't easily break down. When organisms are exposed to these types of pollutants, they accumulate in our fatty tissue because they are fat-soluble. So that fat tissue, instead of passing through the body, right, they do not easily dissolve in blood or urine. And they can slowly be released from that fatty tissue into the bloodstream and eventually impact brain or any other organism. Or any other organ system in that organism. So what are some examples of common persistent organic pollutants? Now you may recognize a couple of these, as a lot of them I talked about in 8.3. So a lot of the persistent organic pollutants can actually also fall under the category of being endocrine disruptors. So things like DDT, which we said was an insecticide, as well as phthalates, which we said come from plastics. We can also see a couple new ones here. So a lot of plastic and paint additives can also be classified as POPs, so like PCBs, percolates, dioxins, which come from fertilizers or combustion. Really anything, like I said before, that's going to be synthetic or human-made is going to be classified as a common persistent organic pollutant, as well as contain carbon. Now, as you can see here in the table to the left there, a couple of them have different varying half-life, some much longer than others. But remember, a part of the reason why they are considered a POP is because they can be long-lasting in the environment. So, looking at some of the specific examples I outlined previously. DDT. This was a common insecticide that was used several years ago. We know that it is now currently phased out. It can be classified as an endocrine disruptor as well. But what wound up happening, we used DDT in order to kill mosquitoes, which can act as pests. But the problem with DDT was that it was fat soluble. And so we saw organisms then consume some of these mosquitoes or even other types of organisms that were exposed to DDT, and we saw it as we moved up the food chain. More and more of these organisms had DDT accumulated in their bloodstream. And the problem with this DDT was that it highly impacted bald eagles. Eagles consumed the DDT-contaminated fish, and what wound up happening is when they went to go reproduce, their eggshells were a lot thinner, they broke very easily, and this caused their reproduction rates to drastically decline. And so this was a part of the reason why DDT wound up being banned back in 1972. But the unfortunate part, because DDT takes so long to break down, we can actually still see some remnants of it in areas that had a high use of DDT. Some other examples of POPs can be medications that come from human medications like steroids, reproductive hormones, antibiotics. They can easily pass through our human bodies, could be released into the environment through sewage treatment, but they can wind up persisting in streams, rivers, and obviously disrupting the systems of organisms that reside there. PCBs, which are additives to things like plastics and paints, can be released into aquatic ecosystems by industrial wastewater. It's very toxic to fish. It can cause endocrine disruption, reproductive failure, and that human exposure tends to come through the animal products. Now, percolates, those are usually given off from things like rockets, missiles, so these are more associated with like a military type compound, can be very common near any military testing type site, tends to remain in the soil after a rocket or missile maybe has been tested, could also wind up leaching into groundwater or runoff in surface waters. Now, how are we exposed to POPs? Well, because they last so long, they can actually be carried from long distances through wind and water. They could even be carried via migrating organisms. We could see them being released via wastewater, especially if they're coming from industrial waste or maybe even human waste. They can enter the soil or water, be eaten by plants, stored in the fat. It could be eaten by humans or even taken via drinking water. So there are many different avenues in which we could be exposed to persistent organic pollutants on a daily basis. So here is our practice FRQ for 8.7 if you want to take a moment and pause the video answering the Edpuzzle and on your notes. Okay, at this point we should have answered our FRQ, which tells us describe how persistent organic pollutants can harm organisms and explain why they can be a problem far away from where they were originated. So here we know persistent organic pollutants, we know do not break down very quickly in the environment, have the ability to build up in the tissues and fats of animals. That accumulation can be toxic, right, to those organisms. In addition, we know that these chemicals, once again, do not break down easily, so they can be carried by wind, water, or even migrating organisms. And so they really can be found in almost all parts of the world. All right, folks, that's it for our video on 8.7. Make sure you leave a question at the end.